Good day everyone, BlazeRaider here. Today I'll be showing you how to create a fake glass dispersion shader, as you can see here. This will work in the Eevee viewport and also in cycles as well. This is running real time in Blender in one of the experimental 2.8 Blender builds, and you can get those builds from the blender.org website. Essentially what this is simulating, or emulating I guess, is a real world phenomenon that you can see here. Although this is a fake photo, but so white light has these different wavelengths of light within it, and these tend to be separated when they interact with this glass medium here. So I've tried to do something similar here, and you can see it's you can judge for yourself how that's working or not. I think it's pretty cool that it's also running in real time as well. So let's jump right in. This is just a default scene in Eevee. So what I want to do is go ahead and add an environment shader. Just add, sorry, not an environment shader, but HDRI to the background. And it's a little bit too bright, so I'm just going to reduce that down. I got this HDRI for free from hdrihaven.com. You can go there and download these as well. It's really high quality. It's a great website, great resource as well. So let's go ahead and delete this lamp and also delete this cube. I want to add Suzanne. It's a bit blocky at the moment, so we'll go ahead and add a subdivision modifier. And you can't see the immediate effects of that right now, and that's because of the way Eevee, the viewport, is at the moment. It is experimental. So we'll go ahead and apply this. You can see it updates, and we'll set this to smooth shading. Also, I want to rotate her around, just like that. There we go. Alright, so let's get to the shader. Let's jump into the node editor here, add a new material, and immediately I'll just go ahead and show you what's happening here. You can go for a glass shader just with the principled BSDF here, and that you can achieve by just increasing the transmission value and also playing with index of refraction here. And you can see that's updating in real time. However, I want to scrap that and add a refraction node. I'll just show you what that does. So in Blender we've got two similar shaders, although they are very different. We've got a glass BSDF node, which will give you glass. So this has two components to it. It's got a refraction component and also a glossy component. You can see it's got like that reflection here. And so you can adjust that. You can see what's happening there. Now we've also got a refraction node, which is essentially the same thing, just without the reflection. And this is what we're going to be using today. So we'll delete the glass node. So essentially, in Blender, whatever color we've got, it's split into RGB. So red, green, and blue. And if we look at our example image here, you can see that red, green, and blue tends to consist, white light, sorry, tends to consist of red, green, and blue in cycles terms. So we'll try and do the same thing here. So let's duplicate these and set this to red, so purely red. We'll set this one purely to green, and we'll set this one purely to blue. Now let's add an add shader node into it and combine these two. So this is incorrect, it should be green. Let's duplicate that and combine these two nodes now. So we get essentially a white colored glass, or a clear glass. Now we could achieve the refraction effect right now just by adjusting these values here. And there you go. That's pretty much, could be the end of the tutorial, but we'll keep going. But using this method doesn't give you any real easy way to adjust the color of the glass. So it's really fiddly. It's nothing that works well. So let's go ahead and add an input RGB node. So this will be our color. And we'll go ahead and separate that RGB into 3 different values. So we'll add a separate RGB node. And then we'll link these in. So red to the red one, green to the green one, and blue to the blue one. So this should work for our purposes. Let's see what happens here. And not quite, actually. Not much is happening. And the reason for this is something to do with Blender, and I'll go ahead and explain what's happening here. So we have an RGB input here, which is let's say some data consisting of an R, G, and a B value from 0 to 1. Now what happens is Blender is outputting this as a yellow, what is this, like an output, and the input is also yellow, so this means that this is an RGB input and output. However, if we come to the output here, it's grey, which means it's like a single digit output, so a value from 0 to 1, or any type of value for that matter. So essentially what we're outputting here is the R value from this input node, which is 1. So essentially we've got white, white, and white. What we need to do is give some color to each of those values. And the way to do that is to add a mix node, a mix RGB node. And we'll just link these two up here. Increase the factor to 1. Set this to multiply. And set the color to red. So now we've got this output value being multiplied by red. So if we decrease this value to say 0.147, this will be 0.147 in red. So now we did the same for the other nodes. So we'll change this to green. I think that's a bug here, just where it's changing both of the colors. Something to look into. We'll change this to blue. There we go. So now we have it working the way we want it working. If we adjust the color here, the color of the glass changes as well. So the last thing that's missing is just the glossy part of the glass shader, I guess. So we'll go ahead and add a glossy node and also a mix shader node, and we'll mix these two together. It's not quite what we want. Let's increase this to 1 so that we've got the full glossiness happening, and decrease the roughness. We'll also add an input Fresnel node as well as the mix factor, and there you have it. That's the final shader there. The way you want to adjust this is, if you want to increase the roughness values, you have to do this individually. So we'll just reset that to normal. And if you want to adjust the index of refraction, you'd want to do this individually as well. So we'll go 1.5, 1.6, 1.7. See what's happening there. You can also see the effect this has if you let's see, add this to another object. So yeah, it's pretty cool. You can imagine there'll be plenty of uses for this. It's awesome that it's real time as well. So that's the end of the tutorial. If you liked the tutorial, please press the like button, subscribe if you haven't already, and thanks for watching.